Hi guys, welcome to the today's session of Divide and Conquer Design and Analysis of Algorithms. In this session, we are going to discuss about the first application of Divide and Conquer design strategy, algorithm design strategy. So the first application itself is finding the maximum and minimum. Now here, what is this problem statement? What is this application? The maximum and minimum problem is a type of optimization problem that seeks to find the maximum value of the minimum of a set of values, or it can be defined as given an array of n elements, A of n, max-min problem is used to find a maximum element from the given array. So here it is used to find a maximum and a minimum elements given in an array. So this problem can be solved effectively in divide and conquer method. So if you go for the general procedure of solving this finding maximum and minimum problem or application, in the general approach, the maximum and minimum element can be found by comparing each element and updating the maximum and minimum values as and when required. So this approach is simple, but it does n-1 comparisons for finding maximum and the same number of comparisons for finding the minimum as well. So it results in a total number of 2 into n-1 comparisons. So that's why. So if your if your problem contains n elements, if your problem contains n elements, that is the elements are indexed from 0 to n-1. If the elements are indexed from 0 to n-1, if you want to find the maximum element and minimum element, you need to do 2 into n-1 comparisons. You need to do 2 into n-1 comparisons. One n-1 comparisons are required for finding the maximum and other n-1 comparisons are for finding the minimum. That is why, because means first we will take the first element. This first element is compared with the element which is present at 1. Now initially maximum contains the first element. Right. Now this value is compared with the next element. If this is the greater value, then maximum is updated with this one. Then it is compared with the element which is present at second index. Then it is compared with the element which is present at third index. Like that it goes for comparing with all n-1 elements. So then only it can find the maximum value. In the same way, initially the minimum contains this element. For finding the minimum value out of all the given elements, it need to do n-1 comparisons as well. So finally 2 into n-1 comparisons that it is doing in the general approach. So it increases the time complexity. If I use divide and conquer method, we can reduce the number of comparisons and we can effectively solve this problem. So what is the algorithm that can be followed in divide and conquer strategy? So here you can see the algorithm. If low is equal to high, here low indicates the first starting element of the array, high indicates the ending element of the array. If low is equal to high and low are the indices of the arrow elements, low index and high index. If these two values are equal, that indicates that array contains only one element. So the maximum itself becomes that element and minimum itself becomes that element. So we written maximum value as A of 0 and minimum value as A of 0. Or you can say that it is A of low or A of high. So here you can write it as A of low or A of high. Since both are same, here it may be A of low or A of high. Right. Now, else if low plus 1 is equal to high. Else if low plus 1 is equal to high. That is, if the starting index is 0, next index is 1. Now, my starting index is low. Now, if my array contains only 2 elements, 0 is my starting index and 1 is my ending index. Now, low plus 1 is equal to high and 0 plus 1 is equal to high. If 0 plus 1 is equivalent to high, that is only two elements are there in my array. Out of those two, here I am going to compare those two elements. So here what I am doing is I'm going to compare A of low with A of high. If A of low is less, then simply I'll return A of low and I'll return A of high. That is, A of low is the minimum element and A of high is the maximum element. Else, I'll return like this. So A of high is the minimum element and A of low is the maximum element. Right? So if that condition is false, I'll return like this. So here you can see, if low is equal to high, array contains only one element, then low minimum itself that one, maximum itself that one. If low plus 1 is equal to high, in that case array contains only two elements. I'll compare those two elements. If this is less, this is the minimum value, and the next one, the remaining next one is the maximum value. So minimum and maximum are returned. Else, if this condition is false, then this becomes the low value. So that's why minimum is A of high and maximum is A of low. Else, if these two cases are not correct, low is not equal to high and low plus 1 is also not equal to high. In that case, more number of elements are there in my array. In that case, we'll divide the problem into subproblems. That is, mid is equal to low plus high by 2. Now, L min and L max, what these two represents are, here when I find mid, at mid we are dividing the array into two subproblems. One is lower subarray, that is left subarray, and other is right subarray. Here L min and L max represents the minimum and maximum values in left subarray respectively, and here these are the values of right subarray. R min and R max represents the minimum and maximum values in right subarray. So here we are calling the same algorithm again recursively. So A of low to mid, that is left subarray, and mid plus 1 to high, that is right subarray. Now, if L is greater than, L max is greater than R max, then in this case, maximum is L max. L's maximum is equal to R max. If L min is less than R min, then min is equal to L min, else min is equal to R min. Finally, we are returning the minimum and maximum values. So I hope that you all understood how this algorithm is designed. Now you can see an example for this. Here we are given some array. Now in that array, here we have totally 8 elements. So the low index is represented with 0 and high index is represented with 7. If 0 is equal to 7, 0 is equal to 7? No, that is false. Else if 1 is equal to 7, that is 0 plus 1, low plus 1. That is low plus 1, that is 0 plus 1 is equal to 7. This is also false. So we are going for else. That is my array contains more than 2 elements. So I am finding mid is equal to 0 plus 7 by 2, which is equal to 3. That is at 3, we are going to divide the array into 2 subarrays. That is the elements 0, 1, 2, 3. Which are present at those 4 positions comes to the left subarray. The elements which are present in the positions 4, 5, 6, 7 comes to the right subarray. So L min is equal to 10. Now, how we are getting these values means, again, we are calling this function. Let us see. Here you can see. We called max min of A03. In this case, again, low is 0, high is 3. Now again, I am going to do the comparison. Again, I will get this max min problem and this max min problem. Recursively, when I solved all these problems, here you can see. Here I will get min value as 25 and max value as 90. These values are written here. L min is equal to 25, L max is equal to 90. Here R min and R max. R min is equal to 10, R max is equal to 15. Now these values are written. And by comparing these values, max becomes 90 and min becomes 10. These two values are written here. Max becomes 90 and min becomes 10. And from these two, here I'll get min is 5 and max is 32. Those values are written here. Min is 5, max is 32. And from this, min is 42 and max is 65. Min is 42 and max is 65. When I compare these two, I'll get min as 5 and max as 65. These are written here. Min is 5 and max is 65. When I compare these two min values, my min becomes 5. When I compare these two max values, my max is 90. So finally, for the given problem, minimum value is 5 and maximum value is 90, like that. So it divides. First, the problem contains 8 elements. After that, it is divided into two subproblems. First subproblem contains 4 elements. Second subproblem contains 4 elements. Again, it is divided into 2 elements. Here, this subproblem contains 2 elements. This subproblem contains 2. This subproblem contains 2 elements. This subproblem also contains 2 elements. Now, out of I am going to compare those 2 elements. One is min and another one is max. That values are written here. Again, this is solved. One is min and another is max. That values are written here. These two are compared. Then one max and one min values are written here. Now, here also 2 elements only present. One is min and other is max. So these two values are written. Here we are comparing those 2 elements. One is min and other is max. Now here again I am comparing those min and max values and I am returning here. Again here comparison is done. We will get minimum and maximum values for the given array. Right. So the time complexity for this maximum and minimum problem using divide and conquer can be represented with the recurrence relation like this. T of n is equal to 0 if n is equal to 1. That is, if n is equal to 1 means only one element is there in the given array. It doesn't require any time to find the minimum and maximum, since that one element itself becomes the minimum and maximum. If there are 2 elements, I need to do one comparison there. So that's why it requires a time of one unit for doing that comparison. If it contains 2 elements, if it contains more than 2 elements, in that case, 2 into t of n by 2 plus 2. So why? Because means here we are going to divide the problem into 2 subproblems. Okay, at the half, first I am going to solve one subproblem, then I am going to solve another subproblem, and finally I am going to merge the solutions. So finally, the maximum and minimum problem can be solved. We can get the time complexity of maximum and minimum problem by solving this recurrence relation. I hope that you all understood the maximum and minimum problem and its algorithm and how to solve that maximum and minimum problem. Thank you for listening.